been converting complex numbers to polar form, and there's another type of problem we want to look at, and this is raising a complex number to a power. Alright, now you've got to think about this. I wrote the Moivre's theorem, and this just allows us to take our complex numbers and raise them to a power and write them in polar form. I guess one of your options would be to multiply all this out. That's not what you want to do. That would take quite a while. I mean, if it was something like I1 minus I to the third, then yeah, go ahead and do it. But in general, we're going to use de Moivre's theorem in order to evaluate this. Alright, so I'm going to do the same thing. Notice that I need R, I need theta. I know what n is. N is my power, so in this case my n value is 10. Alright, my R value is found by taking the square root of a squared, which is 1 squared, plus b squared, which is negative 1, and just simplifying that out. So I'm going to have the square root of 1 plus 1, which is the square root of 2. So there's my R value. And then my theta, the tangent of theta is b over a. So in this case, my theta is going to be, well, we've got to go back. We know the reference angle is 45 degrees. But what quadrant does my angle need to come out of? Well, if I go over 1 and down 1, then I'm in quadrant 4. So this angle is coming out of quadrant 4, which means my theta in this case is 315 degrees, which that just means if I'm looking to see what this complex number is raised to this power, then I'm just saying that this is my R, square root of 2, raised to my n, which is 10 in this case, times the cosine of n times theta, so the cosine of 10 times theta, plus I times the sine of 10 times theta. Alright, so I just plugged that in. Now, if I'm going to evaluate this, I would probably just plug this in my calculator and see if I get an exact value. I caution in saying that because, alright, let's just walk through this. The square root of 2 to the 10th. You know the square root of 2 times the square root of 2 is 2. So if I've got 10 of those, that's just going to be 2 to the 5th. Alright, well that's 32. And then if you plug this in your calculator, you'll see that the cosine of 10 times 315 degrees is 0. So that's just going to be 0, plus I times the sine of 10 times 315 degrees. And if you plug that in your calculator, that's negative 1. So all this is going to simplify to negative 32i. Now, let me just go back to this. This turned out to work really well in your calculator. If they ask for an exact value, you're going to have to use your trig chart and figure out what the exact values are. They're not going to want a decimal. So just be careful there. And I'm going to do one last problem on this. Alright, the last type of problem we're going to do in this section is, unlike de Moivre's theorem, when we took the complex number and raised it to a power, we're actually going to find the root of the complex number. Now remember that if I have a rational exponent, 1 over n, that means the numerator is my power, the denominator is the root. So this is r raised to, or taking the root of r. Alright, and also notice that this is in terms of radians, so I'm going to rewrite all this in maybe more familiar terms to you. So this is actually going to be the nth root of r times the cosine of theta plus 360 degrees times k over n plus I times the sine of theta plus 360 degrees times k over n. Alright, and like I said, k is, you start at 0 and you go all the way up to n minus 1. N in this case is going to be whatever root we're looking for. Alright, so I'm going to do number 78 from this section. And number 78 asks for the cube roots of the complex number 4 times the square root of 3 plus 4i. Alright, so if I'm looking for the cube roots, that is my n value. So n in this case is 3. Alright, let's go ahead and find polar form of this complex number. To put it in polar form, we need r, we need theta. Alright, we already have done this several times. We know how to find r. R is just a squared plus b squared. Or in this case, 4 squared, which is 16. Square root of 3 times the square root of 3 is 3. So 16 times 3, which is 48, plus 4 squared, which is 16. So that's going to be the square root of 64, or 8. So my r value is 8. Alright, my theta is coming from b over a. And if I clean that up, that's just going to be square root of 3 over 3. Alright, make sure you remember that this determines what quadrant we're looking at. So this complex number, if I were graphing that, it would go to the right and up. So I want my angle to come out of quadrant 1. Alright, the tangent of what angle is the square root of 3 over 3 from quadrant 1? Well, that's 30 degrees. Alright, so I've got my theta, I've got my r. So I could actually take this and write this in polar form now. It's just going to be r times the cosine of theta plus I times the sine of theta. Alright, this is in polar form. Now, that's not what this is asking for. This is asking for the roots of this. It's asking for the roots of this. So I am looking to take the cube root of 8, because n is 8, and then I'm just going to fill all that in. So I'm looking at the cosine of 30 degrees plus, alright, I need to talk about what k is here. Alright, so we're plugging in our k. Remember, our k value, we start at 0 and we go to n minus 1. Well, n is 3 in this case, so I'm looking at k being 0, 1, and 2. Alright, so n minus 1 is 3 minus 1, which is 2 in this case. So really, I'm looking for 3 roots. So I'm plugging in k to each one of these. I'm doing this 3 separate times. So this is going to be the cosine of 30 degrees plus, alright, so I'm using 0 first. So I've got 360 times 0, which is 0, over n, which is 3, plus the sine times I of the same thing, 30 degrees plus 0 over 3. Alright, so that's my first one. So this is just going to be the cube root of 8, which is 2, cosine of 30 over 3, which is going to be the cosine of 10 degrees, plus I times the sine of 10 degrees. Okay, there's one of my roots. Alright, that's when k is 0. Alright, I'm going to keep going. I want to know what it's going to be when k is 1. Alright, when k is 1, I've still got r raised to that power, to the 1/3 power, or the cube root of r, so that's going to stay. And I'm doing the cosine of theta plus 360 times 1. So 360 degrees times 1 is 360 divided by n, plus I times the sine of all that. Alright, so this is going to be 30 30 plus 360 is 390 divided by 3, so this is going to be 2 times the cosine of 130 degrees plus I times the sine of 130 degrees. Alright, so that's when K is 1. Alright, we've got one more of those to do. So my last one to do is to find my third root when K is 2. So when I plug this in, I get 2 times the cosine of 30 degrees plus 360 times 2, which is 720 over n, plus I times the sine 30 degrees plus 720 over n, which is 3. I don't know why I didn't plug my 3 in there. Alright, so when we do this, we've got 30 plus 720 is 750 divided by 3 is 250 degrees, so this is going to be 2 times the cosine 250 degrees plus I times the sine of 250 degrees. Alright, so there's my third root. Now, the only thing that I want to tell you here is once you find this first root, you're pretty much, you've got to understand that if I am finding 3 roots, then these are going to be spaced out evenly. And if you think about that, if I'm spacing out 360 degrees, that means that I'm going to add 120 degrees each time. So that's just kind of a little shortcut if you're thinking about that, from going from 10 and then to be spaced out evenly, I would add 120 degrees to that, which would give me my 130, and I would add 120 degrees to that, and that gives me 250 degrees. If you don't understand what I'm talking about, just plug it into your formula. Once you find your R and your theta, and understand that you what you let K be, you shouldn't have any problem.